Okay, so this one's been on my list to talk about for a little bit now, but I haven't really gotten around to talking about it, but it's on these acoustic baryonic oscillations because I've heard these mentioned before and how they're these structures that are from the beginning of the universe, and I just don't think that that's necessarily what's going on here. It may not be from the origin of the universe, but rather they are evidence of a larger structure at a greater scale. So that kind of ties into my theory, right? Maybe these aren't these massive, structures that were formed by sound wave oscillations that got frozen in time, basically, as the universe expanded. Maybe we are looking out and we are able to observe points of higher and lower density because we are looking at larger structures of the universe. And you can only see them when you're really zoomed out because we're probably within one ourselves, but we can't really observe it necessarily because we are within it. And I think that that is interesting. And it would make sense if you think about it, because if you think about how, the sun kind of is this gravity well that is pulling everything in, right? And then the solar system is, inside the galaxy. The galaxy is this gravity well that's pulling everything in. Our galaxy is moving towards what is called like the great attractor or something along those lines, right? So everything seems to be moving towards something else, right? So if you imagine that if this is the case, then when you look out far enough, there should be points where there's a really high density and everything around it should be a lower density because everything else got pulled in. And then at the boundaries of its gravitational reach, that is where you would seemingly see this kind of pileup at, because things that were kind of towards the outskirts would get attracted more towards the outskirts, and things that were closer in would get pulled in, right? So stuff would start to get pulled in, and as stuff got pulled in, everything else would either have to follow suit or move away. And so in the grand scheme of things, this results in a higher concentration and a lower density. And it appears as this sort of pushed out wave, right, that got frozen in time, but it's probably still moving. It's just on a scale that is, it's kind of interesting at this point. At this point now, it's probably more likely that it's perturbating out because the gravitational pull is getting stronger over time, and so there's a stronger pull to move away from, its boundary, its limit of pull. And so that's kind of interesting how that would work. But to me, it would make sense that this is what we're looking at, actually. It's not these sound waves that got frozen in time. These are actual things that are growing and moving and changing on timescales that we can't even fathom because of the scale that they are at. But they are these larger structures and are potential proof towards my theory that, hey, everything is kind of in different scales and everything is combining together to create larger and larger things. And another point that I want to make with this is, to me, it makes more sense for them to be, a gravity phenomenon, as gravity is what impacts celestial bodies, not sound waves. Right? So to me, like the way they describe it, baryonic oscillations, these are described as almost like sound waves, and maybe that's not actually what they are, but it's just a good, thing to relate it to for people to understand the concept. But the fact that these baryonic oscillations behave similar to sound waves, or so we think, to me, this would, these celestial bodies, even if the universe was really small, right, at one point, this is actually probably one of the best proofs I could give. I haven't even thought about making this argument. If the universe was really small at one point, right, and we think that since everything was really small, it was just all atoms, and stuff, if we think that these baryonic oscillations, like if we think the behavior of the universe initially was really tiny and expanded, why would the behavior of matter change? what would make it change between it being really tiny and then it expands out and gets big? Why would its behavior change during that expansion? Its behavior should stay the same. Just because it's expanded out doesn't mean the laws of physics change, right? So if we think that at one point the universe was really tiny and was just baryons all buzzing around, right? And then as the universe expanded, that's when everything kind of consolidated and turned into matter, and then all these things. Why would the behavior of the baryons change from when it was really tiny to when it's really large? What's actually the difference between these 2 points? The difference is that we are zoomed out. Like instead of being zoomed in, we're zoomed out now, right? But if you imagine, really it's actually the opposite. Initially, we thought it's really tiny because we were zoomed out. But now we've kind of zoomed in, and now we're within this really tiny universe that from the initial Big Bang, like it was really small, this like infinitesimally small point or whatever, right? So if you think about it, it's almost like we've zoomed in at an extremely fast pace, and now we are beyond microscopic. We're beyond subatomic. We are so zoomed in now that this really tiny universe is actually massive, right? So if you look at it from that perspective, the behavior of everything shouldn't have changed, right? We've just zoomed in. If it is truly sound waves or, these baryonic oscillations that cause this formation, then that's fine too. It could be the case there, but, then that is proof, that we need that is the proof that we need that the universe is just like atoms, and atoms are what are affected because, so the universe behaves like a bunch of atoms if these are baryonic oscillations that have been frozen in space, right? Well, then that's similar to sound waves, but celestial bodies aren't impacted by sound waves. That's what atoms are affected by, right? So if these baryonic oscillations could get frozen in time on massive scales, then that means that all of the universe, all of the giant celestial bodies in the universe should still behave on the level of atoms, because by having these baryonic oscillations, you're basically saying, hey, they behave just like atoms. I think that that's just interesting because, it's gravity that is what is impacting celestial bodies. It's not sound waves. And so by saying that sound waves and gravity waves are kind of the same thing, that also ties into my theory, because that's what I think, just on different scales, right? And so, it's kind of a point to the fact that gravity and sound waves aren't that different, as I have said before, and that scale is the only thing that separates these behaviors. So, pretty much long story short, these baryonic oscillations that we observe, baryonic acoustic oscillations or whatever we observe in the universe, are evidence towards my theory being correct, no matter how you look at them. I think that there's no way you can look at these and say that my theory does not have some merit based off of that. Because either you look at it as we've really zoomed in, right? Or you look at it as, gravity is just sound waves for larger scales. And then you're back to, then it's all just kind of like this. It's all relative. And, so I just think that, peace out.